Code to Enhance Learning presents the CEL video series for creating projects that integrate computing with the world around us using Arduino UNO. Through this video series, we aim to introduce you to the world of physical computing and the Internet of Things.
Hello everyone, I am Ayush Sankaran, an enthusiastic coder and a regular CEL hackathon participant. I will be your host for today.
Welcome to the 5th episode of the series Let There Be Light. In this episode, we are going to measure light intensity using a photoresistor. A photoresistor or photocell is a type of resistor whose resistance increases or decreases with respect to the luminosity, brightness on the component's sensitive surface. A photoresistor is also called a light-dependent resistor, abbreviated as LDR. One pin of the photoresistor connects to the analog pin of Arduino and the other to the ground. Let us see some areas where photoresistors are put to use. Photoresistors are used in automatic street lights to turn the lights on and off according to the ambient light level. Light dimmers use photoresistors to control the brightness of lamps and lights. Camera flashes use photoresistors to determine ambient light levels and adjust the flash accordingly. Some security systems use photoresistors to detect changes in light intensity and trigger an alarm, for example when a window is broken or a light is switched on. Today, we will measure light intensity using a photoresistor in our project. Let us look at the components we will need for our project. We need the Arduino microprocessor, the jumper wires, the breadboard, a resistor, the photoresistor which detects the luminosity, and the cable to connect to computer. The photoresistor has two legs connected with a breadboard. Using jumper wires, connect any one leg with analog pin A4 and another leg to the GND. Next, take a resistor. It has two legs. Connect the resistor as shown in the image. One end of the resistor is connected to the photoresistor, which is connected with the A4 pin. Another end is connected with Arduino board 5V pin. Now we will make the connections. First, I connect the photoresistor to the breadboard. Next, I connect one end of the resistor to the photoresistor through the breadboard. I connect one leg of the photoresistor to GND of Arduino. The other leg of the photoresistor, which is connected to the resistor, is now connected to the A4 pin in Arduino board. The free leg of the resistor is connected to the 5V pin in Arduino. Once this is done, we connect the Arduino to our computer using the connector cable. Now we will move to coding our project. We have opened a new project on mBlocks and signed into our account. If you do not know how to do this yet, please view the first video in the series, which has instructions to install mLink driver and create your credentials. Once inside, you can rename the project to Let There Be Light and save the project. Now we will connect the Arduino to a project. From the Devices tab, I click on Add button and select Arduino UNO from the list. Then I click the Connect button. Now I see that our device is connected to our project. We also need to add an extension to our project, so I click the Extension button. Here, under Device Extensions, I will use the search bar on top to search Upload. Then, I will choose the Upload Broadcast Mode extension by the developer mBlocks to add to my project. From Events, I bring the block when Arduino starts up. Keep watching the corresponding codes coming up in C language as well. Next, I am going to bring a forever block from Controls group. Now, I go to Upload Mode group and bring Send Upload Mode Message with Value block. I change the message to value. Then for value, from pin group, I bring read analog pin A block. Change pin 0 to 4. Next, we will add a wait block and set the wait time to 0.25 seconds. This completes our device coding. Next, we will code the panda sprite. So I will go into the Sprite tab and write my codes in the panda sprite. I need to add an extension to the panda as well. I click on Extensions and under Sprite Extensions, search for Upload. Now I add the Upload Broadcast Mode extension by the developer mBlocks to my panda sprite. From the Upload Mode Broadcast group, I bring the event when receiving upload mode message. I change the message to value. From the Looks group, I use the Say block to make the panda tell the message value. Before moving further, let me add the backdrops needed for my project. I go to the Background tab and add Camping 1 and Camping 2 backdrops to my project. I go to the Costumes and rename Camping 1 to Dark and Camping 2 to Light. Now we come back to the panda sprite. Now we are going to check the luminosity of light. If the light value is less than 200, we will switch the background to light. We now duplicate this, and if the value is greater than 200, we switch backdrop to dark. Now that we have written the code, let us upload it to the Arduino processor by going into the Devices tab and clicking the Upload button. The code has been successfully uploaded. This brings us to the end of coding the project. Let us test our project. As you can see, the luminosity is greater than 200, so the background is dark. I am going to shine a torchlight on the photoresistor. You can see as the light becomes brighter, the value reduces, and when it reaches below 200, it switches to the light background. We have a fully functional app now. What more can you do with the project? Can you try to increase the number 200 so even at lower luminosity you get the light background? You can go into a completely dark room and see how the luminosity value changes. Now that you know the basics, keep trying different things to make the project more interesting. In the next episode, we will be creating another project called Round and Round, where we will make a servo motor turn clockwise and anti-clockwise again and again. Till then, stay tuned. This is Ayush signing off. Bye.